Welcome to this video, and we're going to create an application that predicts the price of Ford cars. We're going to use an XGB regressor for our model, and I'm going to use Streamlit for the user interface application. So first, let's import the necessary libraries. So we're going to import pandas as PD, import numpy as np from sklearn dot model underscore selection. We're going to import train test split, and then from sklearn we're going to import metrics from sklearn dot metrics. We're going to import the mean absolute error, and then from XGB boost we're going to import XGB regressor, and then from sklearn dot pre-processing we're going to import standard scaler. Now let's run that, and we see we have a mistake. We spelled standard wrong. Let's run that. It's supposed to be scalar with a S, capital S, and let's run that. And you see everything is corrected. I will explain what each of these mean when we get to it. And if you don't have sklearn installed or XGBoost installed, just do a quick Google to show you how you can pip install this into your Jupyter notebook. Next thing we have to do is the data pre-processing. Now we want to load our CSV file into a pandas data frame. Then we're going to call our data set equals pd.read underscore CSV. And in between bracket and quotes, we're going to put the name of our CSV file. And if you're doing it like this, make sure that this CSV file is in the same folder as this Jupyter notebook file, and I have them both in a folder on my desktop. So now let's take a look at our data set. And you see we have our columns, and what we want to predict is the price of, based on these columns, we want to predict the price. And as you see, we have 17,966 rows and 9 columns. Let's check for missing values in our data set, because our machine learning model will run into problems if we feed it with a data frame with missing values. So checking for missing values, data set dot is null, and then we want the sum. And let's run that. And you see we've been blessed with a data set that doesn't have any null values. So now we have to change the categorical values into numerical values. Like we see here, transmission, we need to change automatic into a number, manual into a number, and the same with the fuel type. We won't do the model column because we won't be including it as a feature. So let's see the unique values of the categorical columns that we want to change. So I'm gonna print data set, and we want the transmission column, and we want the unique values. I'm just gonna copy this, paste it, and then I want the fuel type column. And let's run that. And you see this is the categorical values that we need to change into numbers. And we're gonna do that by encoding. So let me just write a note. Coding the categorical transmission column. So I'm gonna put dataset dot replace And in brackets, we put the name of the column. Put a colon. And in between curly brackets, we want to change this automatic. Change that to 0. Then we're gonna do manual. Change that to 1. Then we're gonna do semi-automatic or semi-auto and change that to 2. And let me put single quotes so we're being consistent. And then we want to set the in place to true so that the changes stay in our data frame. Let me just copy this, paste it here, and we're doing the fuel type column. So we're gonna change fuel type here, and then we want petrol. Gonna change petrol to 0. Diesel to 1. Hybrid to 2. Electric to 3. And other to 4. Now let's take a look at our data frame. See our changes. And you see we changed our categorical columns into numerical columns. And the next thing we have to do is split the data into features and labels. So splitting data into features and labels. Let me give this a mark. So we're gonna set X to everything except the price column, because that's gonna be our Y, and the model column. So we're gonna take all the other columns. And we could do this by setting dataset.drop. And we're gonna drop the model column and also the price column. And then we need to set axis to 1. And the 1 means that we're dropping the columns. If it was 0, it would mean that we're dropping rows. And then I'm gonna put values at the end because we're gonna run into a little warning with standard scaler down the line if we don't do this. And next we're gonna set the Y equals to our price column, because we want to predict the price. So now let's take a look at X. And you see it doesn't bring the data frame because we only extracted the values. Let me remove values or just comment it out. And here we have all the columns in the features, and you see that we don't have the model and the price. And then if we look at our Y, we only have the price column. So let me uncomment that. So now let's move on to standardizing the data, and this is why we imported standard scaler. So let me just write a column, standardize the data. And what this means is that we're gonna put all the input features on the same scale. And this will help prevent the model from giving too much importance to certain features because they have a larger scale, and it can also improve the model accuracy. So let's set a variable to scalar equals to this standard scalar that we imported. Control C. And the next thing we have to do is scalar.fit, and we're gonna fit our X. variable that has our features. Fit x, and let's run that. And you see we standardize our data. Then I'm gonna create another variable called standardized x and set that equals to scalar.transform x. Now let's look at our let me just copy this. Let's run that. And you see our data has been standardized. It's been put into a similar range. So now let's reassign this to our x. And the y, we don't need to reassign it, but let's just do it again. And we said this was the price column. And let's run that. And now we have to put our data into training and test data. And this is why we wrote this line in the beginning to import train test split. So let me just do it and I'll explain what that does. So the x train, x test, y train, y test, and we set that equals to train test split. And then we're gonna fit our x and y. And then we want the test size to be 10% of the data, which means 90% of our data will go to the x train and y train, and the other 10% will go to the x test and y test. And then we can set this random state to equals 42. This is marked down. Let me put this into code. And what this means is that if you're following along and you set this to 42, it will split the data the same way as I am splitting it into. If we don't include this random state, then the data reshuffles every time. So after that, I want to see the shape of our x train, and x test. So let me print x.shape, xtrain.shape, and xtest.shape. And let's do the same for our y. So replace this x with y. Now let's run that. And you see our x shape is 17,966 rows and 7 columns. And then 90% was put in our x train, and the other 10% was put in our x test. Same for the y and the y train and y test. So now let's initialize our XGBoost regressor. So here we're gonna load the model. I'm gonna create a variable called XGB_model and set that equals to XGB regressor. And then let's run that. Next, we have to fit our training data into the model. So XGB_model dot fit. I'm gonna fit our X train and Y train. And let's run that. And you see we did just that. So now let's move on to the model evaluation. And normally, well, not normally, all the time, we test our model with the test data, because the test data is the data that our model haven't seen before. But if we want to know if our model is underfitting or overfitting, First, we need to evaluate the train and the test. But we only test our model with the test data. Or we only evaluate our model with the test data. But I just want to do it with the train data so I could compare so that there's no underfitting or overfitting in our model. And I'll explain what that is once I'm done. So let me write a note. Prediction on the training data. Then I'm gonna say training data prediction XGB model dot predict. I'm gonna predict the X train. Next, we're gonna calculate the R2 score on the training data. I'm gonna call a variable score 1. Set that equals to metrics dot R2 score. Then we're gonna put the Y train and the training data predictions. Then I'm gonna find out the mean absolute error. So I'm gonna set MAE to metrics dot mean absolute error. And I'm gonna put this same thing here. So now I'm gonna print R2 score on training data. Then I'm gonna put our score variable that we did up here. And then I'm gonna print mean absolute error on training data. Then I'm gonna put our MAE and let's run that. And you see with the training data, we get an R2 score of 95%. And also the mean absolute error on the training data is 730. Now let's do the same for the testing on our testing data. Control V. I'm gonna change some things around. We want to predict the test. Also change these notes too. Let's run that. And this is what we should go on when we want to evaluate our model. We should only evaluate our model on data that the model hasn't seen before. The training data, it will always be high because it's seen the data before. But the test is what the data that the model haven't seen before. So we'll go by this. And the reason why I wanted to do for both is because I wanted to check for overfitting and underfitting. And overfitting is when the model performs well on the training data but poorly on the testing data. And underfitting is when there is a poor performance on both. So here we see that this is performing very well. So let's ignore this. There's no underfitting or overfitting. So let's focus on here. And we see we get an R2 score of 90%. And it means that the model can accurately predict 90% of the outcomes. And the mean absolute error means that our predictions will be off by minus 917 or plus 917. So now let's make predictions. And again, this is what we test our model on the testing data. So now let's make predictions. So I'm gonna set a variable called input, and I will put values in here soon. And what we need to do is change the input into a numpy array and also reshape it. So let me write no changing the input into numpy array and reshaping. So we're gonna create a variable called input changed equals np.array. Let me call this input data. So input data, then we're gonna reshape, and we're gonna reshape it to one row, and the -1 means to automatically detect the amount of columns or features. So we're only gonna put one row of data here to make a prediction on our car price. Next, we need to standardize the data, or standardize the input, because right now our features are standardized. So we need to standardize the input before we plug numbers in. I'm gonna create a variable called standardize input equals scalar.transform, and in brackets we're gonna put this variable here. Then we're gonna make a variable called prediction, call our XGB model dot predict, and in brackets we put our standardized input. And then we're gonna print prediction. Well, let's print this car price estimation is prediction. So now let's make some prediction. So let's scroll up. And let's say we want to figure out the price for her. So I'm gonna take the year, the transmission, the mileage, fuel type, tax, MPG, and engine size. So 2019 1046. So 2019 let me scroll up again. 1040 for 10,460. Let me see. 0145 40.3. 0145 40.3. Let me see the last two. Last one, engine size 1.5. 1.5. Let me scroll up to just see the price one more time. And the price is 17,500. And let's see what price that our model gave. And you see we get a price of 18,075. What did we say it was? So we're off by about 575. And this is inside our mean absolute error. And remember I said that we're gonna be off by either minus 917 or plus 917. Now let me do another one. Let's do this one right here. So 2015 1 and 7010. already forgot. Yeah, so 2015 1, 7010 120. $67.3 and 1.6. 1.6. Let me see what price it is. So 9,999. And let's see what our model says. And you see we get 10,016. So it's off by about $17. So now that we made predictions, we have to save our model. And we also have to save our scalar. So let me make a heading called Saving Our Model. And to do this, we need to import joblib. And scalar. After we import joblib, let me write a note, save the model. And to do this, we write joblib dot dump, and in brackets, we put our model. And then the next arguments in between quotes, we put what we want to save the name we want to save our model as. I'm just gonna call it the same thing. And we have to give it a PKL extension. Next thing I'm gonna do is save the scalar because we're gonna need this when we're putting in our data into our Streamlib application. So save the standard scalar. Then we're gonna say joblib dot dump. I'm gonna call it scalar. Then I'm just gonna name it scalar dot pkl. And let's look at the folder where we're working on this file. And you see we only have 2 files. And when we run this cell, we will get a file with our model and scalar. So let's run this. Now let's look, and you see we have our model. So now let's go ahead and work on the user interface for the Streamlit application. I'm going to use Sublime Text. So once Sublime Text is loaded, or whatever code editor that you choose to use, open your folder. So desktop, and it's in the YouTube folder. Select folder, and you see all the files that we were working on is here. Next, let's create a new file, and let's save it as, you want to save it in this YouTube folder, and I'm gonna call it carapp.py. And let's save. So now let's import the necessary libraries. Import numpy as mp. Then we're gonna import Streamlit as st. Then we're gonna import joblib so we can load up our models. And that's all we need. So now let me write a little note here, loading our model and scalar. I'm gonna create a variable called model joblib.load, and in between brackets we need to put the file path and the file of our name of our model. So desktop, YouTube, Let me copy this path. Control V. Let me put forward slashes. I'm not sure if I need to do this, but I'm just gonna do it because it's look like it's giving an error. Then we're gonna put slash XGB model.pkl. And then I'm gonna do the same for the scalar. So create a variable called scalar joblib.load. Control V. Then I'm gonna put slash scalar.pkl. Then I'm gonna create a function called car price prediction. And I'm gonna put the input data. And we're basically doing the same thing we did in our notebook. So I can copy this up until, just copy this, Control C, Control V. This needs to be inline and indented accordingly. So we changed the input to a NumPy array and we reshaped it. We standardized the input and then we put our standardize inside the prediction. And the only difference is we need to write return instead of print. So we're gonna return estimated car price. Then we're gonna add, we need to change our prediction to a string or else it's gonna show like an array. So to change it to a string, put string, and inside of that, prediction. And even though we're only gonna get one value back, it's gonna show as an array. So I'm gonna select the first one, which is the only value. And now we need to define the main in our app. So define main. And I'm gonna write a note creating the title. So streamlit.title. In bracket, we're gonna call it Ford car price prediction app. And the next note I'm gonna write is getting the input from user. So we set year to equals st.text input. And then what I want to show is year. And I'm just going to copy and paste so I'm typing less. Four, 5, 6, 7, because it was 7 features. I'm gonna change this to transmission. Change this to quick look at our columns. And it needs to be in order. Transmission, mileage, fuel type. Just gonna modify this one. Tax. I'm gonna give this a small f. MPG for miles per gallon, and also engine size. I'm gonna put a space in between here. Next, let's create this empty variable called predicted price. And then let's put a note here, create a button. So we're gonna use if streamlit.button. I'm gonna give our button name, check estimated price. Then we're gonna call this empty variable. And set that equals to our car price prediction function that we made. And then we're gonna put our inputs that we saved in these variables. So yeah, transmission, mileage. You see Sublime is doing most of the work for me. Tax, MPG, and engine size. Next we're gonna put streamlit.success, which will show our predicted price. And lastly, we need to write some small code to start the program. So if name double underscore on both sides equals double underscore main double underscore on both sides, I'm gonna call our main function that we created. And let's press Ctrl S to save this. And if you want to run this file, we'll open your command prompt, CMD. And we're gonna write streamlit run, and in quotes we put the file path. Put the file path, and then we put the name of this car app file. So car app.py. Let's close the double quotes and let's press enter. Just give it some time to load. And here we created our car prediction app. So let's use the same value that we used down here. So the year was 2015. We'll do a number of examples. I just want to do this to make sure we get the same estimation. The transmission is 1. The fuel type is 1. The tax is 20. 67.3. Wait. Yes, 67.3. And then the engine size 1.6. Now let's click our button. Oh, let's go back to our Sublime text, and we put XGB model here. We're supposed to put this. So let's copy. Let me just delete the XGB in front. And let's save this. Let's go back to our application and check estimated price, and we see we got 10,016, which is the same thing we got here, .308. Let's round this to 2 decimal places. And we can do this by inside of here. We use the round function. And then we want it to be rounded by 2 decimal places. And let's add our closing bracket. Let's press Ctrl S to save this. Let's go back. Well, let's go back and see what we did wrong. Oh, we need another one, because this round bracket is for this one and the string round bracket is for this one. So let's press Ctrl S, go back to our Streamlit app, and you see we rounded it to 2 decimal places. Let's go back, make some other predictions. Let's do this one. So the year is 2019. Transmission is 0, which means automatic, like her. Wait. 2019, yeah. Transmission is 0. Mileage is 114.82. The fuel type is 0, which means petrol. Tax is 145. Miles per gallon 48.7. And then the engine size is 1. Let's check the estimated price. 17,796. And you see we're off by over 1,000. Let's do one more. Let's do this one. And you don't have to plug in these same numbers. You could put any other values you want and get an estimation. So 2019 transmission, wait. We made a mistake here, that's probably why. Transmission was 0 for this estimation. Let's check. See, and now we got a closer value because I made a mistake here. The transmission was 0, which means automatic. So the real number is 16,500. So it's off by like 728. And our model told us when we evaluated our model, where is it? On the testing data, that is going to be plus or minus 917. Let's do one more. Last one before we call it a day. Let's do this one here. So 2019, the transmission is 1. The mileage is 10,046. Wait, 10,460. Fuel type is 0, tax is 145. 0, tax is 145. MPG is 40.3. Engine size is 1.5. Let's see what we got. Estimation is 18,075. Let's go see the price. And you see we're off by 575. So this is how you create an app that could predict car prices.